standard deviation measures minus 2 standard deviation measures. What have you just tracked? 95%, which means you are now 95% confident that you have tracked what? Your average. Think about that with respect to our little blue curve over here, only because that one's still not covered. Back to this blue curve. Think about it. The average of most of those samples was in this range right here, correct? If you take, even if you're in this one, you're underestimating. You're in the 7 to 8 category, but you put the sampling error on there. Have you tracked mu?
Yeah.
Yeah, because mu's at 8.16. You've definitely tracked mu. Suppose you're down here at 6 to 7. 6 to 7, and you put sampling error on there. Have you tracked mu? Yes. Where's the only time you haven't tracked mu? If you landed down here, even with the sampling error on it, it's outside that range, correct? But remember what I said. I didn't say you were 100% sure you tracked it. I said you were 95% sure. 5% of the time you're going to miss it. That's called a type 1 error, and we'll deal with that in Math 244. But 95% of the time you're going to, even when you're up here, if you stretch it out, it's going to be in there. And that's what this statement says. This statement right here says that average you're looking for is going to fall within 2 standard deviations or 2 standard errors. The reason it's called a standard error, again, is more or less a contextual one. It's because you're trying to find mu. So you're trying to infer mu from data, from sample data. Does that kind of make sense? So that's why it gets the fancy name of standard error. That's all. Now, I love Athena's question. She had a fantastic point about the migraine. If I have a migraine, I want to know roughly how much relief I'm going to get. Well, here's the deal. Standard error is inversely proportional to the sample size. What does that mean, inversely proportional? Yes. As one goes up, the other goes down. And you noticed this, didn't you? You caught this. As our sample sizes went up, the curves got skinnier and taller, less variation. We pick up precision as sample sizes go up. Now that word precision might not make a whole lot of sense to you, so I've got 4 images on the board right here. 4 target practice. Let's step outside the realm of statistics for just a moment. The targets represent average. You're trying to hit average. You're trying to hit the center of the target. One of those targets shows high accuracy, high precision. One shows low accuracy, low precision. One shows high precision, low accuracy. One shows low precision, high accuracy. Pick one and tell me what the one shows that you want to.
No precision, high accuracy.
No precision, high accuracy is where?
Right.
Top right corner. That's actually high precision, low accuracy.
Right. Low accuracy, but high precision because it's people in the same place.
What would precision be?
Tight shot.
Tight shot, consistency. Consistency versus lack of consistency. Lack of consistency would be low precision. Tight groupings would be high precision. So the high precision ones are top right and bottom right. So the top right one is, you're not accurate because you're missing the target.
What's your precise?
But where you're hitting precise. So for that gun, you'd have to adjust the sight.
But you're wrong all the time.
You're wrong all the time, but you're so close every time you're wrong. You're so close to that wrong answer. So all you got to do is adjust where the sight is, and you'll get down to that bottom right, which is high precision, high accuracy, correct? What's top left up there, friends? What's top left up there?
Low on both.
Low on both. You're missing the target, and you're missing it poorly. As a matter of fact, sometimes you miss what you're actually aiming at so much, you hit what you should be aiming at. You see what I'm saying? So you've actually hit the correct target a couple times, but completely randomly. Those are the outliers. So the bottom one, we've actually got accuracy because we're targeting the middle, but the group's all spread out, so you're lacking precision. Now here's the beautiful thing about the central limit theorem that you're learning about right now. You are guaranteed these. Because you're guaranteed what? Say that nice and loud. You are guaranteed the average on accuracy on the average, Francesca. Remember what the part 2 or part 1 I think it was. The center of the distribution is at the average. So you're guaranteed accuracy. You are targeting the middle of the curve at the average. You're not guaranteed how wide your curve is, but you can make your curve more narrow by doing what? By repetitions, increasing your sample size. So this would be a smaller sample than this. And if you had yes, that's right. This would be a smaller sample than this. And if you made an even larger sample, what would happen to the gunshots? Closer, closer, and closer. It asymptotically going down to a single point, never getting there because you can't go to 0. Is that fair? You guys buying that logic? Ish. Okay. Now, this is the last point, and it's the least important of the whole batch. There is a number out there that some of you may have heard before in some of your classes, that you have to have a certain sample size. I mentioned that we sit with Stephanie Howland talking about a minimum number of samples. 30 is like a baseline cutoff. I mentioned it to you as a historical fact. I don't know where the number comes from. I have never found a paper that proves to me why 30 is used. As a matter of fact, I've seen some papers that prove why 30 is not necessarily true, although it's used the most repetitively. So, all I want you to do is to realize this. As your sample gets larger, the bells become more perfectly bell-shaped and tighter in. That's all you got to remember. But the number 30, has anybody ever heard that, the 30 sample size from the bell curve? Oh, okay, you heard it here first then, I guess. I'm going to tell you this, though. I can't find any support that proves to me why 30 is good, other than anecdotal evidence. We'll talk more about that in 244. Speaking of 244, that's the end of 243. Yay! You survived an entire 10 weeks of this guy. How many times did I repeat jokes in here? Very, very frequently. Very, very frequently. I apologize for that.